resistance of a system of resistors. There are two methods in which different resistors can be joined. One is the series combination. Here you can see R1 and R2 connected in series combination, and other is the parallel combination. Here R1 and R2 are connected in parallel combination. You can understand series and parallel combination in a better way. You see, in the first circuit, a bulb is connected from one end of the battery, and from other end of the bulb, next bulb is connected, and so on. So here you can see current will flow from one bulb to the other bulb. So this is series combination. But on the other hand, in the second circuit, you see each bulb is separately connected from the battery. You can see here, if wire of first bulb is cut or the bulb fuses, the second bulb and third bulb will keep glowing. And similarly, if wire of third bulb is cut or third bulb fuses, current will keep flowing in the first and second bulb. So this combination is the parallel combination. You see here in the first case, it's a parallel combination case. Both bulbs are separately connected from the battery, and in the second case, it's a series combination. One bulb is connected from the battery, and from other end of that bulb, next bulb is connected, and the other end of that bulb is connected to the other end of the battery. You can see here, one wire of one bulb is broken. As a result, this bulb is not getting current, but the second bulb is still glowing because it is a parallel combination. On the other hand, you see one part of the wire is broken at a place. As a result, both the bulbs are not glowing because the circuit breaks if even one part of the wire is broken. So this is a series combination. Now we'll learn to get the combined resistance or the equivalent resistance of three resistors connected in series. But before we derive the expression for combined resistance, we must know few important points regarding series combination. In series combination, each appliance, whatever resistance it has, get the same amount of current. So we can say in series combination, each appliance get the same current, and that is equal to current of the circuit. But here potential difference get distributed. To understand in a better way, if we take here R1, R2 and R3 as three resistors, so R1 will have potential difference V1, R2 will have potential difference V2, and R3 will have potential difference V3 across its ends, and the total potential difference, total means the potential difference across the circuit, will be equal to V1 plus V2 plus V3. Or we can say, if wire has negligible resistance, then potential difference get distributed in the series combination. So we know that now in series combination, potential difference is distributed. That means V will be equal to V1 plus V2 plus V3. We can take it as equation 1. And from Ohm's law, we know that V is equal to IR. Similarly, we can get V1 on R1, that will be equal to IR1. We can take it as equation 3. We can also get V3 and V2 and can take it equation 5 and 4 respectively. Now, putting the values from equation 2, 3, 4 and 5 in equation 1, we get V, that is equal to IR equal to V1, that's equal to IR1 plus V2, that's IR2 plus V3, that's IR3. So we get the equation IR equal to IR1 plus IR2 plus IR3. Now, taking I common on both sides and cancelling, we get R is equal to R1 plus R2 plus R3. So, we can say combined resistance of three resistors connected in series is equal to sum of the resistance of each individual resistor. Here are two examples to understand the combined resistance of few resistors connected in series. If we take three resistors of 2 ohm, 3 ohm and 4 ohm respectively and connect them in series, its combined resistance R will be equal to R1 plus R2 plus R3, that will be equal to 2 plus 3 plus 4, that is 9 ohm. So it's very simple to get the combined resistance in series combination. Similarly, if we have three resistors of values X ohm, Y ohm and Z ohm, its combined resistance will be equal to X plus Y plus Z ohm. Before we go to get the combined resistance or the equivalent resistance of certain number of resistors connected in parallel, we must know few things regarding the parallel combination too. In parallel combination, current get distributed. So, current of the circuit I will be equal to current on R1, that's I1, plus current on R2, that is I2, plus current in R3, that is I3, or we can say current get distributed. And if resistance of the wire is negligible, then each resistance will have the same potential difference, that will be equal to potential difference of the circuit. Or for example, if we take this V value is 12 volt, then R1 will also get 12 volt, R2 also and R3 also will get 12 volt, and that 12 volt will also be the potential difference across the whole circuit. So considering these 2 points in our mind, now we go to get the equivalent resistance of three resistors connected in parallel. You can see in this circuit, by the rule we know now that I is equal to I1 plus I2 plus I3, that is current get distributed, and take it as equation 1. From Ohm's law, we know that current is equal to potential difference by resistance, or I is equal to V by R. We take it as equation 2. By using this equation, we can get values of I1, I2 and I3 as V by R1, V by R2 and V by R3 respectively, and take it as equation 3, 4 and 5. Now, if we take the values from equation 2, 3, 4 and 5 and put it in equation 1, we will get I, that is equal to V by R, will be equal to I1, that is V by R1 plus I2, that's V by R2 plus I3, that is V by R3. So, we'll get V by R equals V by R1 plus V by R2 plus V by R3. Taking V common in both sides and cancelling it, we will get 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3. Or we can say the reciprocal of the combined resistance of three resistors connected in parallel is equal to sum of the reciprocal of the resistance of each individual resistor. Here are few examples to calculate the combined resistance in the parallel combination. If there are two resistors of 3 ohm and 6 ohm connected in parallel, we can get the combined resistance here. As we know, 1 by R equal to 1 by R1 plus 1 by R2. Putting the values of R1 and R2 as 3 ohm and 6 ohm respectively, we get 1 by R is equal to 1 by 3 plus 1 by 6. And so, taking 6 as LCM, we get 1 by R is equal to 2 plus 1 by 6. That's 1 by R is equal to 3 by 6. So, R will be equal to reciprocal of 3 by 6, that will be 6 by 3 equals 2 ohm. what is very important thing here, you have to remember that often you get 1 by R and forget to write R. So when it is parallel combination, your answer is not 1 by R, it's R. So you have to write the reciprocal of 1 by R, and that's the value of R as your answer. Here you can see in the second circuit there are 3 resistors of 1 ohm, 2 ohm and 4 ohm and connected in parallel. So to know the equivalent resistance, we use the formula 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3, putting the values of R1, R2 and R3 as 1 ohm, 2 ohm and 4 ohm respectively. We get 1 by R equal to 1 by 1 plus 1 by 2 plus 1 by 4. Taking 4 as LCM, we get 1 by R is equal to 4 plus 2 plus 1 by 4. So 1 by R will be equal to 7 by 4. Therefore, R will be equal to reciprocal of 7 by 4. That will be 4 by 7 ohms. So, till now, we have learned to get the combined resistance of 3 resistors connected in series and to get the equivalent resistance of 3 resistors connected in parallel. Similarly, we can change this method of derivation for 2 resistors or 4 resistors too. Thank you.